Now, uh, we can easily perform elementary row operations on MATLAB. Am I correct? Sorry, on matrix using MATLAB. We can easily perform elementary row operations on a matrix using MATLAB commands. That means we can convert the matrix into row reduced echelon form, diagonal matrix, etc. That means we can solve the system of equations also. Am I correct? And that I will touch later. So that is the way to perform. That is the way to perform elementary row operations on a matrix. Now I have a matrix like this. I have a matrix like this. Okay. So if you give F all row elements of first column is equal to empty braces. As usual, the first column will be eliminated. Okay. This is common. Now I have a matrix like this. I want to find out the maximum element. How to do that? I want to find out the maximum element of the matrix here. Maximum element of the matrix. So guess any command. If you give max of A, what will happen? What is this output? Output is this output is what is this output? I got like this output.
Maximum in each column it is giving.
Maximum in each column, but I need maximum element in a row, in an entire matrix. How to do that one? Actually, max. If you give a max of A, I am getting maximum element like this. Maximum element in this row column 96. Maximum element in this column 93. The maximum element in this column 71. The maximum element in this column 70. But I need maximum element in a matrix in the given matrix. Yes, like max of A. So already we have row vector with a max A. If you give max A, we'll get a maximum element. Max A, we'll get a maximum element. Am I correct? This is 96. The next question is I want to know the index of the element. How to find out the index of that element? How to find out the index of the maximum element? Suppose I am taking another matrix A of 36, 16. A of 16 is equal to 96. I am taking. I have two maximum elements. Similarly, E of 15 also 96. I am taking. So I have three maximum elements. Now we have four maximum elements. Am I correct? If you give max of same logic, max of A, you get it display only one maximum element. But if you give like this, in that case also we'll get the maximum element in this row, in this column, maximum element in this column. In this only one maximum element. In this two maximum elements are there. 96 meters. How to identify the how to find the index of the maximum element? Any guesses? Any guesses? Any guess? How to find out the maximum index of the maximum element? Indices of the maximum element. So I will copy what will happen. Will we get with this command? Lakshmi Priya has posted one comment. Will we get max of A? It's showing first element is the maximum element. First element is 42, 42 is not a maximum element, first of all. Am I correct? Any guesses? I want to find out the index of the maximum element in a matrix, not in a row. Sorry, not in a column. Not in a. Why it is showing 1? Because with this command, we will get 96, 93. Am I correct? 696, 96. Am I correct? From that, we are getting the index. That first element is maximum element. It is showing like that. Any guesses? Find is equal to find of A is equal to max of max. Something she is telling. Find of A is equal to max of A. Double equal to. Any error? One more bracket is missing. Okay. Fourth element, 10th element, 15th element, 16th elements are maximum elements. Yes or no? Fourth element, 1, 2, 3, 4, 8, 9, 10, 15, 16. Find is equal to A is equal to max of max. So here we should know what is this one. Suppose how the relational operators work on matrix. But I will start. That's correct command only. For example, A is with me. Suppose A is equal to 10. If I give like this, what will happen? It will show, it will give array. No element is equal to 10 in this matrix. Okay. What I am doing here, 96 max of A is equal to max of A. Okay. That will show, that will give here 1 is the here matrix. Here 96 is there, here 96 is there, here 96 is there, here 96 is there. Now if you give a find, it gives the find command gives indices of the non-zero elements. Okay, A is equal to max of A. Okay. There is another command. You see this one. If you give, what will happen? Max A of colon. If you give A of colon, if you give A of colon, all elements will be displayed in each element, column, it display column wise. 42, 92, 76, 96 is first row. So first column. Next, second column. Next, third column. Next, fourth column. Okay, na? I hope you understand. So like this also, now we have a array now. Okay, we have an array. Whether it is a column or a row, not a problem for me. Am I correct? If it is a column or a row, the operations are same. So we can convert. We can find the maximum element using the find command also. Find of A is equal to max of answer. Here answer is our A colon otherwise. A colon means all elements. Colon always we can take it as a all. Both we got 4th element, 10th element, 15th element, 16th element. So the maximum. Okay, with this I am closing this maximum element. The same thing we can minimum of min also will work. Min also will work. Okay, min also will work. Next I want to tell you one important command. A is with me. Flip LR. This is very interesting command. Flip LR of what will happen? What is the output? Flip LR. Flip LR. What happened? Flip LR. Flipped left to right. The matrix will be flipping, flipping a coin. Flipper. Flipping. Flip L to left to right. So left to right means this column will become to first column. This column will become to second column. This column will be placed in third column. This column will be placed at fourth column. Just reverse. Flip LR. Flip UD. UD means you can use up and down. My A is this one. This column will be written at first column. Reverse. Flip up and down. Flip left and right. Okay, I hope you understand. What is one of the advantages of this flip LR? Suppose I have a matrix A. If you give DIAG of A, I forgot to tell this command, DIAG of A. This will give first diagonal element, principal diagonal elements. 42, 4, 74, 96. That is sum of DIAG of A. That is nothing but, what is this one? Trace of A. Am I correct? Sum of DIAG of A. That is trace of A. Okay. Trace of A. Now A is with me. We can display principal diagonal elements. Next question is how to display second diagonal elements. Second diagonal, whether it is correct word or not, I don't know. Second diagonal elements 96, 66, 66, 96, 85, 96. How to display second diagonal elements? How to display the second diagonal elements? That is here flip LR. Using flip LR, we can display the second diagonal elements. If we take a flip LR, what will happen? This element will come to this place. This element will come to this place. Am I correct? This element will come to this place. This element will come to this place. Am I correct or not? Okay. So DIAG of flip LR of A will use second diagonal element. 66, 96, 85, 96. Did you understand the point? Okay, next. Now we know this is one of the advantages. So many advantages are there with flip LR. A is with me. Now DIAG is there. DIAG of A. So these elements we obtain these elements. How to display these elements? 66, 96, 96. The elements above the principal diagonal elements. Next, how to display these elements? Next question, how to display below the principal diagonal elements? How to display these elements? Second diagonal elements. About whether this word is correct or not, I don't know. DIAG of A, 1. What will happen? 66, 96, 66, 96, 96. DIAG of A of 2. That means we will get 68, 77, 70. 68, 77, 70. 66. Suppose if you give minus value, below principal diagonal elements will be displayed. Okay. Similarly, f minus 2, f minus 3. Okay. So there is another command. Suppose if you give DIAZ of a vector 1, 2, I forgot to tell you this 1, 2, 3. We'll get a diagonal matrix whose diagonal elements are 1, 2, 3. We'll get diagonal matrix whose diagonal elements are 1, 2, 3. Okay. If it is a matrix, it displays diagonal elements. If it is an array, it create a matrix. It will create a matrix. Okay. Suppose DIAZ of A. DIAZ of A. It displays the diagonal elements of A. Since A is a matrix. If we give DIAZ of a vector, it will create a matrix. That's it. Okay. Next command is A is equal to, I'm taking this is the matrix. If you give like this, reshape, how many elements are 36 elements? Reshape of 6, 9. We'll reshape the matrix as 4 by 9 matrix. 4 by 9, 4 rows, 9 columns. Total 36 elements. We have to concentrate on that. 2, 18. 2 rows, 2, 18. 2 rows, 18 columns. 2 rows, 18 columns. 3 rows, 12 columns. Right? Reshape. This is also very useful command. You will see this one. Okay. 4, 4, 5, 6, 6, 7, 8. Like this. 8, 8, 8, 8, 8 it is not possible, you know. 9, 2. Am I correct? 36 only. 2 elements, 36 elements. Oh, not that. 9, 4. 9, 4. 9, 4. 9, 4. Then reshape A, that is 1, 36. This is nothing but 1 row, 36 columns. We are making as, we are converting as row vector. That is nothing but A, all elements, transpose. Both are same. A, all elements, transpose. Both are same. Last row, this is the last. Previous command is last elements 31. Same. Both are same. This is about reshape. I have matrix A. B is another matrix. B. A is one matrix, B is another matrix. Wait, B is A is one matrix, B is another matrix. So how to make it as horizontal concatenation? Horizontal concatenation, vertical concatenation. You can match horizontal concatenation. A is one matrix, B is another matrix. If you want to match horizontally, you have to give like this. This we well known, we know this one. This is vertical concatenation. First I am writing A. Next, below that A, I am writing B. Okay. Now I am constructing a matrix D is equal to A ones of 3, B is of 1, 2, 3. I think you can now you can guess the answer. A, this 3 by 3 matrix. B, ones of 3. B, this is the matrix B. This is diagonal matrix whose diagonal elements are 1. Okay. Okay. These are the. Now I will open my PPT. I will open my PPT. Not this one. Online classes are MATLAB basics. So we'll check it one by one whether anything is. If you want to find out the transpose of A transpose, if you want to perform addition of two matrices, A plus B, A minus B, A star B, A dot star B, perform pointwise multiplication, BIAZ. We get the diagonal elements of A, rank of A. We get the rank of the matrix, det A, we get the determinant, inverse A and B horizontal, A and B will be merged horizontally, A and B will be merged vertically, Ij element will be displayed. Okay. We can Ij element, ith row jth column element by 5. First row will be displayed, second column will be displayed, second row, third column, second row, third row, second row, third row will be displayed. First column, third column. If you give this one, second row, remove the second row. Displays all the elements of A. A means matrix A in column wise. Polynomial of it. We get the characteristic polynomial, roots of polynomial A. Okay. We get the eigenvalues of A. Eij of A. We get the eigenvalues of A. Flip LR. Flips the elements A. Elements of A. A means matrix A from left to right. It displays the second diagonal elements, eigenvalues. EY. So these all these things I told them. EY of MIN. Identity matrix, zeros, ones, random, diagonal elements, submatrices, reshaping. Yes, that's it. So now I will go to the basics of matrix. Yes, all basics are covered. Okay. Now I will 2 or 3 minutes I will spend on this worksheet. Then I will go to the next one. Not this one. Any doubts on the assignment? Any doubts on the assignment? Worksheet 5. Worksheet 5. Any doubts on the worksheets? If you have any doubts, you can tell. I will explain. Oh, this is the next worksheet. Where is the fourth worksheet? This one. Assign the first row of A to a vector called x1. x1 is equal to A of 1 comma column. Assign last 2 rows of A to an array y, to an array called y. Y is equal to last two rows. Two rows. Last two rows means 2 and 3. Compute the sum over columns of A. Okay, these are different commands. Okay, I will take this. Okay. Okay, somebody has given one packet. I don't know, I forget her name. He is there. Some of you, what will happen? Sum of first column means sum of second column means sum of third column. No need to give sum of like this. Sum of E of 1 comma column. This is first column. Like this. First row this one. First row this one. First column, I need column wise. This 120. First column. Next, how to find out the sum of column wise elements, row wise elements? Sum of rows. Compute the sum over the rows of A. How to do it? Sum of A transpose. Okay. Sum of A transpose. Next, you do this one. Next, determine which of the following statement is correctly executed. That you have to check properly. What to enter the commands. Okay. Nothing is there. Any commands you have to identify. Explain the result of the following commands. Execute the commands. If you get an answer, that's fine. If you get an error, identify the error. Given an array A from the problem 3, provide the commands that will assign even numbered columns of A to array called B. Assign even numbered columns of A to array B. How to do that one? For example, A is 5 by 6 by 6 matrix or 10 by 10 matrix. Assign even number of columns of A to array called B. Is 10 by 10. Even number of columns to assign even number of columns of A to array called B. Capital B is equal to small b. How to do this? Even number of columns. Colon, true colon, yeah. Those are the even numbered columns. 57, 47 like this. 5400 this one. 87, 58. 34, 90. 65, 73. Even number of columns.
Sir, third bit M1, sir. 3M.
From A2. What will happen? That is same as?
Sum of A column, A transpose.
Those sums. These two are same. L and M are same.
Yes.
L and M will be same. Whatever it came to my mind, I wrote there. Nothing is there. Okay, next. Assign the odd number of rows to an array called C. That's why I say convert A into 4 by 3 matrix. Okay, compute the reciprocal of each element. That you know, 1 by 1 dot by E. Compute the square root of each element of E. Square root of each element of E. SQRT of E. So with this, today I will send one assignment. Okay. We do that one. So we can spend some more time on matrices and arrays, but I have to cover all the topics. So with this, I am closing basics. Now I am going to applications, some applications of this MATLAB, applications of this MATLAB. But I will tell you later. While programming, I will come back and I'll do that one. Meanwhile, I'm not teaching mathematics, but I need some information. Don't feel like teaching mathematics and all this. Some of the students are young, budding students are there. I want to ask one question, then I will move to my next topic. That is very important to me. That's why I'm asking the question. The question is, this is for students who completed MSc recently or those who are doing MSc. Like some Pavan is there, Haripriya, some Pavana, some VIT, some student called me yesterday, 2 days back. Is that name? I forget his name. Pavan is the Pavan. VIT is doing Pavan. Lakshmi Priya, I know why, because she attended 1 or 2 workshops. Lakshmi Priya. Okay. So my question is, so what is the value of, very simple question, what is the value of anything something by 0? Suppose I have a value, I want to know this value. This is important to me now. What is the value of this? Anything by 0. Infinity? You can tell your answers. Based on that, I will start the program. Not define one answer. Next, anything on somebody code. Not define. Synonymous. There is Pavana something, Pavana Charana something, I forget his name. Not defined. Very Mamata Kumari, not defined. Okay, next. Any answer, other answers? Not defined. It is not defined. Infinity for a question in Mother. Infinity. Next answer came. Okay, next. Not defined. Mandeshwari, Katam writing. Not defined. Not defined. Sir, Varuk, nobody is Yakub Basha Muhammad in video. He supported you. Okay. Okay. Vasudevan. Only 2 answers are coming. One is not defined, one is infinity. Which value I have to take now? Infinity. Synonymous. Again, he is supporting infinity. Okay. Suppose anything by 0 is equal to infinity. Two by 0 is equal to infinity. Am I correct? You are writing your term like this. So 3 by 0 is also infinity. 3 by 0 is equal to infinity. So now onwards I will teach some mathematics and I will go to my topics like this. Okay. 2 by 0 is equal to infinity, 3 by 0 is equal to infinity. So equality is there. Am I correct? What is an equation? What is the definition of equation? Equality. Equation. What is the definition of an equation? EQUATI. What is the definition of an equation? What is the definition of an equation? When will you call some expression is an equation?
Left hand side equal to right hand side.
Left hand side equal to right hand side. Two quantities are equated by equal. Okay. If we are telling this value is equal to this value. Two quantities are equated by equal. This value is exactly equal to this value. If you have an equation, definitely we can perform all elementary operations. Like kindly mute your mic. we can perform all elementary mathematical simplifications. That means you can take cross multiplication also. 2 is equal to 0 into infinity. Okay. At present, I don't know what is the value of. So, but it is valid. Why? Because we are equating 0 into infinity. So there is a transitive property. If A is equal to B and B is equal to C, then A is equal to C. A is equal to B, B is equal to C, then A is equal to C. 2 is equal to 3. Transitive property. By transitive property, so I can say that 2 is equal to 3. So whatever it may be, I don't know the value of 0 into infinity. Let us assume that this is equal to infinity. I am taking 0 into infinity. 0 into infinity. 3 is equal to 0 into infinity. 0 3 is equal to 0 into infinity. By transitive property, A is equal to B, B is equal to C. Therefore, A is equal to C. 2 is equal to 3. Okay, that means this is not correct. Anything by 0 is not equal to infinity. So, what is the specialty of this word? There is a word equation. There is only one word in mathematics which contains all vowels A, E, I, O, U. According to my knowledge, this is the only word in mathematics, mathematical word, which contains all vowels. Okay, there is a specialty of this equation. Okay, 2 is equal to 3. What is the value of? So, we should not say anything by 0 is an infinity. We should not say. What is the value of anything by 0? In the simple logic is anything by 0 is not defined. But anything by 0 is always not defined. It is not an infinity. Because very simple. Very simple. Because so the simple logic we can say like this: 2 by 3. So I usually tell like this example: 2 by 5. You take one thing. The meaning of 2 by 5 is you take one finite quantity, divide into 5 equal parts. Divide into 5 equal parts and take 2 parts. You take one quantity, divide into 5 equal parts and take 2 parts. That is the meaning of 2 by 5. 2 by 4, 1 by 4. 1/4 of the syllabus is over. We divide the entire syllabus into 4 equal parts. Divide one quantity into 4 equal parts and take 1 part. 1/4 of the syllabus is over, completed. What about 0 by 5? We take 0 by 5. We take one finite quantity and divide into 5 equal parts and take 0 parts. That means you are taking 0. If you apply the same logic to 0 by 5 by 0, what will happen? You take one finite quantity, divide into 0 equal parts. Can we do that one first? We cannot. I'm taking 5 parts, which is meaningless. Can we divide a finite quantity into 0 equal parts? We cannot divide. Can we do it? Impossible. Cannot do it. We cannot do a finite quantity into 0 equal parts. Okay, in that case, taking 5 parts is meaningless. So this type of numbers are not defined. Anything by 0 is always not defined. This number is not defined. Not defined. not defined. So anything by 0 is not an infinity. It is not defined. Tan 90. Tan 90. Sin 90 by cos 90. Sin 90 by cos 90, 1 by 0 is not an infinity. It is undefined. That's why we are telling the slope of y-axis is not defined. The slope of y-axis is not defined. The slope of a line parallel to y-axis is not defined. We are not saying infinity. We are not saying infinity. Okay. We'll come back again with this slide. This slide is important again. Okay. Anything by 0 is always not defined. Okay, then we have to use the word infinity. There is the next question. Next question. Next question. Suppose if we take a simple table, x and 1 by x. What will happen if x is equal to 1? 1 by x is 1. X is equal to 0.1. 1 by x is 10. As x is equal to 0.401. 1 after 5 zeros. Okay. 1 after 4 zeros or 1 after 5 zeros? 4 or 5? 3. 4 or 5? 4 I think, no? 1 by 0. 4 or 5? 5 zeros, huh? 4 zeros, huh? I can't doubt. 4 zeros or 5 zeros? 5 zeros, yes. Okay, the process of equating one thing with the other. What is this? Okay, 5 zeros. As x approaches to 0, suppose if we take 0.100 zeros 1, we get 1 after so many zeros, 1 or 1 zeros like that, maybe. Okay, as x approaches to 0. As x approaches to 0, the symbol is x tends to 0. As x approaches to 0. That means x is not equal to 0. The meaning of this symbol is x is not equal to 0. As x approaches to 0, 1 by x is approached very large quantity. Very large quantity. That large quantity we call it as infinity. Infinite number is a not defined number, but we cannot count. Orally, I am telling just to give an idea. As x approaches to 0. So here there is again big question. What happened if you approach from negative side? This is 0. X is equal to 1. I approach like this. Am I correct? 0. I approach like this. What will happen if you approach like this? From -1 to 0. This is -1. This is -1. Minus. This is minus. This minus. This minus. It approaches to minus infinity. It minus approaches to minus infinity. As x approaches to 0 plus, means positive side. From right hand side, if it approach to 0 from right hand side. If you approach to 0 from right hand side, limit extends to 0 plus f of x, that is 1 by x, is infinity, positive infinity. Whereas if it extends to minus infinity, extends to 0 minus, that is minus infinity. That means in this case we say that limit does not exist. There we have to use the word does not exist. Left hand side limit is not equal to the right hand side limit. There we have to use the word does not exist. The value does not exist. Derivative does not exist. Mod x, if you take f of x is equal to mod x, derivative does not exist at x is equal to 0. Okay. There we have to use does not exist. If you take 1 by x square, if you take this one, 1 by x square, left hand side limit is same as the right hand side. That is equal to infinity. In that case, we can say limit extends to infinity. Sorry, extends to 0. Sorry, extends to 0. 1 by x square. We can write as an infinity. But what is the value of f of 0? Suppose if we take this f of x, f of 0, not defined. F of 0 is not defined. Whereas limit extends to 0, 1 by x square, infinity. Okay, I hope you understand the difference between infinity and not defined numbers. Next thing, something by 0 is infinite, not defined. What about 0 by 0? There are some numbers sin x by x at x is equal to 0. Sin x by x at x is equal to 0 is 0 by 0. These numbers are called, these type of numbers are called. What is the name for that one? What is the name for that one? Indeterminate forms. What is 5? Everyone is asking 5. What is 5? What is 5?
Previously, you asked number of zeros to be given.
Okay. Okay. These are the numbers. That's why we are telling. That's why we are telling in the lower classes, very elementary classes, we define rational numbers. The numbers which are in the form of p by q. Immediately we say p by the numbers which are in the form of p by q. Immediately we write q is not equal to 0. This number is valid when if and only if q is not equal to 0. The numbers which are in the form of p by q, q is not equal to 0. P comma q are integers called rational numbers. The rational numbers. So this is very important condition. Okay. So with this brief introduction, I am going to plotting techniques. So because we need, so most of the times we'll generate sin x by x sin 1 by x curves like that. At that time, you should not get it out, no? Tan x curve. So, and one more thing, if you see that, I close this one. No? Oh, it is there. So, tan x curve will be like this. Whether you observed or not, if you see the standard textbooks, don't see roadside books. There will be some dotted lines like this. Tan x curve will be like this. Not like this, sorry. X is equal to 0, no? Tan x. It will be like this. Whether you observe this type of curves or not, I don't know. there will be data lines. They will give a data lines or line. So here the function is not defined. The meaning is at this point the function is not defined. This x is equal to pi by 2, x is equal to pi by 2, x is equal to 3 pi by 2, x is equal to 5 pi by 2. At these points, the curve, this they will give some gap here between these two. As x approaches to pi by 2, 0, x tends to pi, x approaches to pi by 2, tan x approaches to positive infinity from this side. If you approach this one, whereas if you approach from this one, tan x approaches to negative. Negative. That is the meaning here. Now, with this brief introduction, I am going to plot techniques. Whether it is there or not. The syntax of MATLAB not only helps us for calculation, but also helps us in data analysis and visualization by plotting curves and waveforms. It provides a variety of functions for displaying data as 2D or 3D graphics. The commands to produce simple plots are surprisingly simple. The syntax for 2D plot is plot x data, y data. Plot x data, y data. If you give this command, we'll get a 2D plot, x versus y, x versus y, x versus y. So what is suppose if you want to plot it? Very simple. You can easily understand this concept actually. Suppose I want to plot y is equal to sin x, for example. Y is equal to sin x. Y is equal to sin x. In 0 to pi by 2. 0 to 2 pi always. What will we do? What will we do? We take some points in 0 to pi by 2. Am I correct, sir? We take some points. X is equal to 0. We calculate y is equal to 0. X is equal to 0. Y is also 0. Am I correct? The point is first point is 0, 0. We take another point. X is equal to some value. We'll get ordered pairs. We'll get ordered pairs like this. We plot the points in graph paper. We plot the point 0, 0. Next point. Next point. Next point. So it will come like this. We'll plot this curve. Sin pi is 0. Sin 3 pi by n minus 1. Let a curve. Points. Again sin 2 pi is 0. So then we'll plot this curve. We'll join the points. We cover like this. If you want to plot a curve, we need some x values in the given interval. In the given interval 0 to 2 pi. Okay. We need some values in the given interval. Now how can we take some points, some points in the given interval using MATLAB? Our interval is 0 to 2 pi. I have to take some points that I can generate an array between 0 to 2 points in so many days. X is equal to 0 colon 0.1 colon 2 pi. Am I correct? 2 pi. I will get few points, finite number of points from 0 to 2 pi with an increment 0.1. I will get these points. Okay. That means first ordinates I have. No, all first ordinates I have. Okay. Next thing, what I have to do? At each point, I need sin x value. Now I have an array x. I have an array x. Okay. I have an array x. I can calculate sin x values by taking a simple command y is equal to sin of x. Am I correct or not? If you take a sin of x at each point, at each point of this array, we have sin x value that we will store in y. Now I have x data in this interval. In this interval, x data, I have x values in the interval 0 to 2 pi. At the same point, I have sin x value. I stored in y. We have an x data on y data. So if you want to get a plot, if you want to get a plot, what we have to do? Plot x comma y. Plot x data comma y data. Then we MATLAB displays 2D plot. Okay. So I'm taking this one. X is equal to 0 colon 0.1 colon 2 star PA. Y is equal to sin of x. I have x values and y values. Okay. What is size of x? For example, if you have doubts, 63 points are there in the closed interval of a comma b. At the same points, I have at the 63 points, I have y value. Okay, I have x value now, y value. The new plot of x comma y. Okay, so this is the y is equal to sin x curve in 0 to 2. In 0 to 2. In 0 to 2. Okay. So this window is called figure window. This window is called figure window. This window is called figure window. We done means we'll get a grids. Okay, we'll get a grid. This window is called figure window. Now we are familiar with. Now new window came into new window came. One is most command window, command history, workspace. Next window is figure window. One more window, help window. This is a powerful window. Help window. Okay, so we are familiar with 5 windows now. Am I correct? We are familiar with 5 windows. With this, today I am closing my session. Tomorrow I will continue. Tomorrow, not tomorrow. Day after tomorrow. Command window. Command history. Workspace. Window. Help window. Figure window. Now we are familiar with these windows. Okay. With this, today I am closing my class. Day after tomorrow we meet again. So I will tell different techniques in plotting. Okay. Different techniques available. Plotting techniques available in MATLAB. Rajesh sir, I am leaving.
Okay, sir. Thank you, sir.